Another way to read this is log of A base B equals x. What did I say different? Okay, depending on who taught you to begin with will really depend on how you read this, honestly. Okay, I was taught log base B of A equals x, and so that's how I say it. Okay, but it's also not wrong to say log of A base B equals x. A math teacher that used to teach her a couple years ago, that's how she read it, and when kids would go from my class to her class, they would be confused because we said it differently. So I'm trying to make sure that you know that that's not the only way to say it. There are multiple ways. Okay? And there may be a way that I don't even know about yet. Okay? Why do we use logarithms? This is another big deal here. Why do you think we would use a logarithm? What's different from here than here? What can I get to here that I couldn't get to here? The exponent. Okay? It's a way to isolate the exponent. A lot of times what we say is if the variable is in the exponent, you have to use logarithms to solve for it. Okay? So let's rewrite these exponential forms into logarithmic forms. First of all, is 7 squared equal 49? Yes, so I know I'm writing something that's already true, right? I just need to write it in logarithmic form. Well, the base is the base of the log, so log base 7. And somebody, a second ago when I was asking what's this called, somebody said a subscript, didn't you? Where did you get that vocabulary? Chemistry? Where else might you get that vocabulary? Like in computers, right? A little baby letter or number a little lower than everything else is a subscript, right? Okay? So we can think of it that way because it's kind of acting that way, kind of. Okay? So log base B of, so 49 equals 2. What about B? Log base 3 of 243 equals 5. C. It must be harder because there's a fraction. No. Log base of 136 equals -2. Log base 9 of 27, 1.5, good. E, log base 4 of x equals 9. Now, we wouldn't need really a logarithm here to solve for x, would we? We would just have to know what 4 to the 9th power was. Okay, but remember, we're just rewriting stuff, but there's some things I want you to see. What about f? Ooh, that looks familiar, doesn't it? How would I rewrite this? Log base 2 of 20 equals x. And if I could figure out how to put that in my calculator, couldn't I solve for x? Oh my goodness. What about this one? Log base 8 of 32 equals x. Can you go the other way? Do it. Out loud. 2 raised to the x power equals 64, right? What about I? X squared equals 64? Wait, so if something's written in a logarithmic form and there's like maybe a base that's an exponent, could I solve for that now? Oh my goodness. What about J? 64 squared equals x. Wait, what if we were doing this one on K? What the heck? There's no base. You know how when we have like just a variable like b, right? If I just have a b like b. What's the exponent on this? How do you know that? Because it's implied. What is the coefficient of this? A 1. How do you know that? What if I have this? What am I doing? I'm taking the square root of 2. How do you know that when there's not a 2 there? It's implied, right? Okay? When it just says log, there's an implied base. And that implied base is 10. Okay? I think you probably could have figured that out because we don't know what base it is, but when you square it, it's 100. Some base squared is 100. Well, what's squared is 100? 10. So how would we rewrite L? 10 to the negative third equals x. So what about M? Ten to the fourth is 10,000. Is 10 to the fourth 10,000? Okay. What about N? 10 to the x equals 1 over 10. For the record, what would x be in that case? Negative 1. Good. Okay. So the other worksheet that you have is what your homework is for this evening. Okay. And we're actually taking it one step further. We are rewriting the log from logarithmic form into exponential form so that maybe we can solve it. Okay? So how would I rewrite this into exponential form? 9 to the third power equals x. Oh my gosh, that's such a hard problem to do. What does x equal? Nine squared is 81. What's 9 to the third? 729. What about b? Say it again. 3 to the x equals 9. Oh, yeah, that's easy, right? Because x equals 2. 3 something equals 9. But that's really ugly. What if it was like 3 to the x equals 8? Can we figure x out? Yeah, we'll talk about that later. Is that okay? What about c? X to the third equals 64. How do we solve that? I mean, obviously you know what the answer is, but do you know how to get it mathematically? So raise it to the 1/3 power, like we did last chapter, right? Cube root, x equals 4. What about d? 7 to the 4th equals x. Do you know 7 to the 4th off the top of your head? $24.01. Okay. What about e? X to the 5 halves equals 32. Wow, I really wish we would have just gotten done with the chapter of exponents and fractions. Oh, yeah, we did. Okay, so we raised both sides to the 2/5 power. So x equals what? How do you know that? The 5th root of 32 is 2. 2 squared is 4. Remember, the bottom is the root, the top is the power. Can you at least act like you remember that a little? Okay. Yeah, you were absent. That's why you don't know that part. Okay, what about f? (10 to the negative 4th equals x? X equals? (1 over 10,000) because it's really 1 over 10 to the 4th, right? And we know 10 to the 4th is 10,000. So what about g? 9 to the x equals 1 over 81. How do you know x equals negative 2? Oh, we just got done with that lesson. Yay! What about h? 10 to the x equals 10,000. X equals 4. Determine the value of x in these equations. It would be 4 to the 0 equals x, right? What is 4 to the 0? So x equals 1. Okay, what about j? How would I rewrite this? 6 to the 0 equals x, so x equals? Okay, what about k? 8 to the x equals 1, so x equals 0. What about this one? 10 to the x equals 1, so x is 0. Okay, so for homework, I need you to do the back. Okay? Everybody clear on that? Okay. Any questions about the beginning of logarithms? Guys, listen to me real quick, please. Any questions about the beginning of logarithms? This is one of those that I go pretty slow in the beginning because I really need you to understand some basic concepts. If you can write something from logarithmic to exponential form and back from exponential to logarithmic form, this chapter is going to be a lot easier. Okay?